Algebra 2. Today we're going to look at section 6.4 in the textbook on rational exponents. We're going to learn how to write a radical as a fraction or rational power by using the power on the radicand as the numerator of the fraction and the index number on the radical becoming the denominator of the fraction. So, in other words, when I have like the nth root of something to the a power, I'm allowed to take the radicand, write it down, divide the power by the index, which is the same thing we've done in the past. The difference today is we're going to learn how to write square roots, cube roots, fourth roots, and so forth as fraction powers instead of just simplifying them. So, for example, the first learning target is learning how to convert between radicals and fraction or rational powers. Question number 1 is the square root of 5. We can see that the radicand is 5, the power on the radicand is an understood 1, and the index is an understood 2. We can change the square root of 5, writing it as a fraction power, by bringing the base down, or the radicand. The power on the base becomes the numerator of the fraction, and the denominator is the index number. And so in the past few sections, we have done like square root of 5, and we've just kind of left it there because we knew that no perfect square would divide into 5. This section is teaching us how to write it a little differently, and that way we can know that radicals and fraction powers are really the same thing. Question number 2, the cube root of 4. Again, we're converting between radical and fraction power. Please notice in number 2, the radicand is 4, the power is 1, and the index is 3. A good way to convert it over to a different form is to use the base of 4, power becomes numerator of the fraction, and the 3, which is the index, becomes the denominator of the fraction. So the cube root of 4 is the same thing as 4 to the 1/3. If I typed this in the calculator and then typed in 4 to the 1/3 in the calculator, I would get the same answer. Question 3, the fourth root of 8a to the second b to the third. Noticing that the radicand has 8 to the first, a to the second, b to the third. Looking at one at a time, you would take the number 8, do 1 divided by 4 to convert it to a fraction, power. Then you would go with the a term, the a variable, and take the power of 2 and divide it by 4. 2 divided by 4, though, simplifies to 1/2. So, as always, please make sure your fractions are reduced form. Then you would bring down your b, and you would convert that to 3 divided by 4. 8 to the 1/4, a to the 1/2, b to the 3/4. Okay, you try going backwards now. 4 to the 3/2. Well, if we're given a fraction power, again, same steps. You're going to put the 4 underneath the radical. Remember, the numerator is always the power on the base, so my power would be 3. And the denominator of this fraction is actually the index number. So 4 to the 3/2 is the square root of 4 to the third. Now, one thing I want you to notice is that if the directions just said to convert, it may be okay to leave your answer like this, but you also know to simplify underneath. So if it's 4 to the third, that's actually 4 times 4 times 4, and so 64, if I did have to simplify, would be a good way to write that. And then we know the square root of 64, and that is 8. But it really depends on the directions. So if it does say convert and simplify, 8 would be the best answer, and it's just asking you to do a conversion, which is what I typed here, then we actually could stop there. Question 5. For x to the 4/5, well, we would take the base, bring it down, we put it underneath the radical. The numerator, top number of the fraction, is going to stay with the x as the power. The 5 is the denominator of the fraction, it's going to go as the index. The 5th root of x to the 4th is a good way to write x to the 4/5. Learning target 1 is, again, learning how to go back and forth between radicals and rational or fraction powers. Okay, second thing, big concept is reviewing like properties that we've had in the past. Properties for rational exponents are also the same, which is really good. The same as properties of integers. So we don't have to learn a whole new set. We can just use what we've learned in the past. So the product rule applies. Product rule, again, remember, means if I see like terms with the times sign in between, I need to multiply the coefficients and add powers on the same variable. Power rule is another rule that we've learned in the past. You're going to multiply power outside parentheses by all powers inside parentheses. Third property that applies to rational exponents is the quotient rule. If I see a division bar in my problem, I'm allowed to divide the coefficients, subtract powers on the same variable. And number 4 is called the negative power rule. You're going to change the position of the term with the negative power. In other words, if the term is on top of the fraction and it has like a negative exponent, you will need to move it to the bottom or vice versa. And remember, as you're moving it, changing its position, the power becomes positive after you move the term. So if you have like x to the negative 1/2, first off, you're paying attention to the negative. Negative exponents cannot be left in your final answer. So you're going to take this entire term to the bottom underneath the division bar. You're going to convert it from a negative to a positive, like that. And if there's nothing left on top, remember you need a placeholder, so that would be 1. And then you would have to deal with the rational power. We know that learning in this section that fraction powers are just a different way to write a square root, or radicals I should say. This one has a denominator of 2, so that's why I said square root. The base is x and the power is 1. Okay, so the sample I just gave you is just making sure you recall the negative rule. Negative means relocate, move it to the bottom of the fraction, make sure you change it to a positive. And then if you do have a fraction power, you can always convert to a radical, and then don't call it quits there. You would have to rationalize because you can't leave a radical underneath. So all the rules we've learned in the past still apply, and we just have to keep adding to our tools. And that way we know good ways to simplify these questions, because they're all going to look different. Okay, next we're going to do some simplification. So in your notes, again, write everything down. First example is 8 to the 1/3 times 8 to the 2/3. What I want you to notice, obviously, is that we are dealing with fraction powers. Good news is I don't see a negative there on either one. Also, I want you to notice there is no letter or variable in this problem. So because there's no variable in this problem, I don't need to necessarily use the entire rule. It is a product. It does say product. I'm supposed to multiply. But if we're going back and looking at what we just wrote down, the product rule says to multiply coefficients. Well, we know from the past that coefficient is a word that indicates the number being multiplied by the variable. So in my question, number 1, I do not see a variable here. So be really careful because this is a common mistake. If they do not give you a letter, you are not supposed to multiply 8 times 8. You are supposed to drop down the base as the same. Then you are supposed to use the rest of the rule, which says add powers, okay, on the same base or same variable is how I worded it. But if it's the same base, that's probably a better way to say it, then you are allowed to add these powers. And remember from the past, when you're dealing with fractions, if it's adding, these have to match. They do. So you're just going to add the tops. 1 plus 2 is 3. You're going to keep the same denominator, which is 3. And 8 to the third, 3/3, which sounds weird, is just 8 to the first. And so this is the simplified answer to this problem. And you could always check too to make sure, like when you type it in your calculator, that you get the same thing. But I also want to caution you against relying too much on the calculator and letting it be your brain, because if you do that, you're not going to really understand the rules and be able to apply them in situations where you can't use your calculator. So make sure that you know how to do both. Question 2. 5 to the 1/2 raised to the 4th. I notice a fraction power here. I do not see negative exponents, which is really good. I do have a power raised to a power, and so based on the 4 properties that we reviewed, this one is a power rule, which means if I have a power on the outside of parentheses, I'm supposed to multiply it by all powers on the inside. And so in this case, I'm supposed to drop my 5 down. I'm supposed to multiply 1/2 times 4. Recall from the past, and again, I know you can use your calculator, but when you're multiplying fractions, you don't have to have a common denominator. You're just going to go straight across. And I'm going to make 4 a fraction by placing it over 1, because 4 divided by 1 is still 4. We're going to go straight across, and you'll get 4 over 2. 4/2. Well, that reduces, so we're going to write this as 5 to the 4/2 is 2. We'll show that step. And then we need to reduce or simplify even further. 5 squared is 25. So don't ever leave me an answer that you know it, or leave me a step here that you think's the answer. Make sure you simplify it when you can, especially if that's what you're asked to do. Now, let's try number 3. Number 3 is 9 to the negative 1/2 power. I notice a negative and a fraction. This one I'm going to model to the side here. Your job is to first get rid of the negative power by moving the entire problem underneath the fraction bar. As you move it, the negative changes to positive. If you don't have something up here, you always put a 1 as a placeholder. Next, it does say simplify, so I have to keep going. I will now want to convert that to, instead of 9 to the 1/2, I'm going to draw my radical symbol. I'm going to drop my base down. That's a 9. Again, I've said this several times today, but the top number stays with the base. That's a power. The bottom number is the index. So 9 to the 1/2 is the same thing as the square root of 9. And then you want to simplify that. And so instead of 1 over radical 9, you're going to write 1 over 3. So 1/3 is a simplified answer to 9 to the negative 1/2. Okay, then we're going to move to number 4 for the next one. We've got 7 to the 3/2 divided by 7 to the 1/4. Again, notice on your screen we have fraction powers. Nothing's negative, no negative powers, I should say, so that's good. Also notice there's no letter in this problem. It still is a quotient rule. There's still a division bar there, but let's look back. Quotient rule says to divide coefficients. Well, I don't have coefficients, so I can't divide. But I can subtract the powers on the same base. So I'm going to go back over here. I, again, am not going to divide 7 by 7. I'm just going to drop the same base down. I'm going to subtract. You always take the top fraction first, slide it to the side, subtract the bottom fraction from it. You cannot subtract fractions unless the denominators match. And so now you're using your calculator, and you're also hopefully doing this in your head as well, as quickly as you can. 2 and 4 both divide into 4. That's a common denominator. This one did not change, so we do not change the top. 1/4 is still equal to 1/4. We did, however, change the denominator here, so we can't just drop the 3, because 3 divided by 2 is not the same as 3 divided by 4, obviously. So 2 divides into 4 2 times. 2 times 3 is 6. Run that through that again, because it may have been a while since you've seen that. When you're trying to find a common denominator and you've changed the bottom number, you say, how many times does this divide into this? Whatever that answer is, you will now multiply it by the top number, the old top number, to get the new one. Once you have a common denominator, you're going to just work left to right. 6 minus 1 is 5. You're going to go ahead and subtract the numerator, but keep the denominator the same. So you're going to take this and put it as your power on 7. And then it does again say, always keep looking at the directions, it does say to simplify. So the next thing you would do is change it to a radical, or use your calculator here, but I'm going to drop my 7 down. My 5 is going to stay on the 7. My 4 is going to become the little index number. So we're dealing with a 4th root this time. 7 to the 5th power is the same thing as 16,807. And then you would go through and see if there's any powers of 4 that would divide into it. And if not, you would leave it alone. Alright, example 5, negative 32 to the 4/5. Again, remember our directions are simplify. So the first thing you want to do is notice that the number is actually negative. We do not have a negative exponent. So we're going to drop our number down. We're going to place it underneath the square root, or the radical, I should say. We're going to look at the numerator of our fraction. It's going to become our power. Because I see a negative underneath the radical, I probably want to put it in parentheses just to make sure I don't make a sign error. And then I want to make the denominator of that fraction be the index number. You would need to show the next step. You would need to now calculate. You can use your calculator. Type in the parentheses with the negative 32 raised to the 4th power. You get this huge number. You're then going to take the 5th root of that. And when you do all of that, you should get 16. You can practice at home making sure that you type it in correctly as well. Really important that you know how to use your own calculator. Alright, look at number 6. Question 6 has a variable involved. I also see a negative exponent on the y as well as a negative exponent on the entire quantity. I notice that it is in parentheses as well, and I could actually use the power rule. So I think that would be a good thing for us to do. I'm going to go ahead. There's a 16 to the 1st, y to the negative 8, raised to the negative 3/4. So we can either write it as 16 to the 1 times negative 3/4, which is negative 3/4, y to the negative 8 times negative 3/4, which is positive 6, and then do a conversion. So like leave y6 where it is. It's a positive power. Relocate this because it's a negative exponent and move it to the bottom. Like that. And then continue. Top stays the same. Now the bottom we're going to convert into a radical form. 16. 3 will stay with the 16. 16 to the third power, but we're going to do a fourth root of that. Keep moving forward. Next, you would want to simplify the radicand. So you would want to do 16 to the third power, which is 4096. You would drop y6 down, and then you would do, like I said, the fourth root. And let's see what happens here. Fourth root of 4096 is just 8, and that's a good answer. And you know to stop when you don't see any issues with the denominator. And you've got reduced fractions as well. Another option you had, because when I started number 6, I said there's another way. One thing you could have done also from the beginning is just take the entire parentheses to the bottom. If you wanted to do that, that would work also. The issue here is you're only going to get rid of one of the negatives off the power, like that one, and not necessarily this one. So that and one on top, so then you'll have to figure out how to simplify this. So this may take a few extra steps, but it actually would work either way. Well, let's move to number 7 next. On number 7, still the directions are simplify. Notice that this one's in radical form. You have a couple options here. You can either change everything over to fraction powers and work through it that way, or you can do what you've been taught in the past and like rationalize. But I'm kind of looking ahead, and here's what I'm seeing. If I do like the 8th root of x to some power, kind of figuring out what that question mark there, what that would be. Issue here is, see, that's an 8. You wouldn't be able to multiply these because remember in multiplication the rule is you have to have the same index. So second thought, that's probably not the best plan. That would get really, really messy. You wouldn't even be able to do the numerator here. So I'm going to scratch that idea. I'm going to go with my original thought. I think it'd be better just to change this over. So when you see radicals, try converting it to fraction powers. From the past, we didn't do this. We just looked at it and said, well, the 4th root of x to the 3rd, there's nothing I can do there, and we'd leave it alone. Now we're learning in this section that we can take the power on the variable or the term, use it as a numerator, divide it by the index. So 3x to the 3/4 is the same as this part. Then on the bottom, the 8th root of x to the 2nd becomes x to the 2/8. 2 divided by 8. And then remember my comment, always, if you see a fraction that can be reduced, do so. So I'm going to go back and change the denominator. Instead of x to the 2/8, I'm going to call it x to the 1/4. And now I want you to notice that my terms that I have, both of them have the same letter, which is really good. And that means I can subtract these powers. Quotient rule from Algebra 1. And so you're going to say x to the 3/4, let me put this to the side, minus 1/4. X to the 3/4 minus 1/4. Same denominator, so that makes the problem easier. Subtract 3 minus 1, you get 2. Leave the denominator alone. 2/4 reduces, so 1/2. X to the 1/2. And then notice again, and I haven't made this comment yet, but if the problem has radicals in it, it's a really, really good idea to make sure your answer is a radical. That's what the key most likely will do. I'm going to say that again. If your problem has radicals in the problem, it's probably a good idea to put your answer in radical form. And if it's like fractions, unless it simplifies like this one, like right here, it's a good idea to like use fraction powers unless it simplifies. Try to keep your answer in terms of what your problem looked like. It's a good way to say it. Okay, last one for today. X to the 1/4 divided by y to the negative 3/4, all raised to the 12th power. What I'm noticing here is the variables are different, so I cannot subtract these powers. Okay, so I can't use quotient rule. But what I can do is get rid of this big power of 12 on the outside, and I can use the power rule, which says multiply the power on the outside by all powers on the inside. So we'll try that. We're going to drop our x down. We're going to multiply 1/4 times 12. 1/4 times 12. Just kind of showing you on your screen right now. Again, when you're multiplying fractions, it's easy. You don't have to have anything match. You just go straight across. 1 times 12 is 12. 4 times 1 is 4. 12/4 reduces to 3. Denominator, we drop our variable y down. We now multiply negative 3/4 times 12. We go straight across. That's negative 36 over 4. And negative 36 over 4 is negative 9. Okay, we look at our answer. What we should notice is there's a negative power exponent on the bottom, and we cannot leave that. The rule says to relocate it and change its position. So better answer would be for me to drop down my x to the 3rd. You don't want to move it. It's positive, it's good. But this one's going to move to the top as y to the positive 9th. And because these are different letters, you cannot add these powers. So this is a good answer. Okay, so again, this is section 4, making sure you know how to convert between a radical and a fraction power, forward and backward. Also, making sure you understand that you are allowed to use the product rule, power rule, quotient rule, and negative power rule on any types of problems. It can be integer powers or fraction powers. That's why we're allowed to use it in this section. And when the directions say simplify, you want to give me your best answer so that it cannot be reduced any further and that you have not violated any of the issues, like don't leave a radical on the bottom or don't leave a fraction power, because fractions are the same as radicals. Fraction powers are the same as radicals. Okay, so we'll give that a try.